Okay, so now we move ahead in the integration. Standard formulas you already studied. Now we go for some methods for integration. So one we did, if you just recall, if you remember, if you have function composed with linear function like this, integral of sine 2x. So now answer to this, you imagine this is x, and integral of sine here minus cosine 2x upon the coefficient of x by 2 plus c. This much we know. This is one way of integrating functions which are specially composed with linear function. This is a linear function, remember. Suppose one more example, if I take, I have, let me write 10 raised to 7x plus 1. Suppose such function. Now here function is composed with this linear function. This is linear function. You can imagine like 10 raised to x. This is like x. What's the integral of a raised to x? A raised to x upon log a. So upon log 10 to the base e, that is to the base 10, upon the coefficient of x, which is 7. So you're into 7 plus c. This is the integral. So this is specially for linear function. But if the function is not composed with linear function like this, suppose I have, let me consider such function here, x into e raised to x square plus 1 dx, such function. Now this is not linear here, this is a quadratic function. So in such functions, what we'll do in such questions, we introduce some new variable. So here it is sometimes called method of substitution. Method of substitution. We substitute some new variable, so it's known as method of substitution here, remember. Method of substitution. This is very important and powerful method for integration. Very important method. This is very important method for integration. 99% questions in integration we can do by this method, substitution. What we mean by substitution? We take some new variable. Depends upon the question. You will realize as we move further, and we reduce into the standard form. For example, I'll take this one only. Let me take this question. X into e raised to x square plus 1 dx. So you cannot integrate directly e raised to x square plus 1, but if I have here like x, then I can integrate. So what I'll do, this is called substitution. I'll put x square plus 1 equals to some new variable, t. Usually in integration, t is used. So I'm taking this substitution. Now here you have dx. This will be e raised to t. So your question should be in form of dt. So for that we differentiate this, differentiating. What's the integral of x square? 2x. 1, 0. Integral of t with respect to x, which is dt by dx. I'll take dx over here. So 2x dx equals to dt. Now you see here, this much is already there. This is there. This much, x dx. So I'll take 2 on the other side. So x dx equals to half dt. 2 is constant. So now this reduced to, you see here, this reduced to x dx. That is half being constant, I'll keep outside, dt. You just look at here, x dx. This and this, half dt, and this is e raised to t. Now this is very standard integral. What's the integral of e raised to x? That's e raised to x. With respect to x, here integral of e raised to t with respect to t. So which is nothing but e raised to t plus c. Right? So this function reduced to standard one. This was not the standard. With the help of this substitution, you can convert this entire integral into this standard one. So this is called substitution method of substitution, remember. Okay, and now t was just intermediate variable, so we need to express in x final answer. So half e raised to, what was t? That is x squared plus 1 plus c. This is your final answer. You can verify whether this is right or wrong. Just differentiate this by chain rule. You will get exactly given function. Just you find the derivative of this one, you will realize it is exactly the given function. So this is what substitution. Now how to take the substitution, I'll tell you as and when we have some standard functions. But in general, you will learn by practice and observation, remember. It's not like differentiation. We don't have ready chain rule. Now we will realize differentiation is much more easier than the integration, because there are no standard rules for integration. There are, but in general, not always applicable. Okay. One more example. Suppose here, next question. Let me see, I have this integral of, let me write 2x into sine of, let me write here 3x squared into sine of x cube plus 1 dx. We want to integrate this. Now here the function is not linear, remember, but you can take this one equals to t. Okay, this is a substitution. Put x cube plus 1 equals to t. So what's the differentiation here? 3x squared, derivative of 1 is 0, equals to dt by dx. Directly I'll write here. So you can write this. You can drop this step. As I've shown here, you can drop this step. No need to write even differentiating. But this is a differentiation. So you can drop this step. From this directly you can write this, remember. So that's what I did here. From this I'll repeat. What's the derivative of x cube? 3x squared. Derivative of 1 is 0. Here you have dt by dx. dx I took on that side. I hope this is clear to you. Now you see this is already ready there in the function. This much. Fine. So this selected one becomes dt. So this is equals to, this much is dt here. And this is nothing but the sine t. This is nothing but that bracket was t. So this is sine t dt. Now this is a standard function. Every time in integration questions, your question reduced to one of the standard formula, remember. So this is a standard formula. What's the integral of sine t? It is nothing but the minus cos t dt. Here, sorry, plus c. But what is finally t? T is nothing but the x cube plus 1 plus c. So this way you will get the final derivative, remember. Sorry, final integration, I'm sorry. So here you can verify, if you differentiate this by chain rule, you will get exactly the given function. This is the function. Here the integration is in form of dx. Here the integral is in form of purely t, remember. You cannot have mixed variables. Such things will not be there in integration, like x and dt and so on. This is not allowed. Mixed variables are not allowed in integration. That is possible in differentiation. Here this is purely in form of t. This was purely in form of x. So that should be there in your mind, remember. Okay, one more question. Suppose I have this. Let me write integral of here log x the whole raised to 4 upon, let me write x dx. Okay, now again this is not a linear function, cannot be integrated, so I'll put the substitution. You know derivative of log x is 1 upon x, so log x equals to t. T normally variable for substitution. After doing this, always what's the next step? Differentiation. What's the derivative of log x? 1 upon x equals to, what's the derivative of t with respect to x? It is dt by dx. So I'll write dt here and I'll take dx on this side. Now you see here, this much is already ready with you. X dx, this is already there in the function. So this is equals to, this is t raised to 4 dt. T raised to 4, x dx become dt new variable. Now can you integrate t raised to 4? Yes. That is nothing but the t raised to 5 upon 5 plus c. Raise the power by 1 if you remember, x raised to n plus 1 upon n plus 1, that's the formula. And what is t finally? That is nothing but the log x the whole raised to here 5 upon 5 plus c. So this is your final integral. The integral of this is this. You see the way of writing properly. You must write. You can verify if you, I'm just reminding you, no need to do every time this. If you differentiate this function correctly, you'll get exactly the given function, that is this much, remember. You can verify if you want, I'm just reminding. Okay. Let me do one more question here. You know integral of, for example, tan x, which you already stated by standard formula. But let's prove it here. Integral of tan x. We want to write this. You already written, that is log of mod of sec x. You must have written minimum 10 times. The answer to this is log of mod of sec x plus c. Why this? Let's see this. Okay. So what I'll do, I'll write here, this is equals to, you know, sin x upon cos x. Now here I'll take the denominator function equals to t. Now one question might be there, why denominator function equals to t? You will learn by practice, you will realize, right? Practice gives you answer to all these questions. I'll put cos x equals to t, substitution method, remember. Now once you take the substitution, always the next step is differentiation. So I'll differentiate this. What is the derivative of sin cos x minus sin x? Dx equals to dt. You know I've dropped one step. Actually dt by dx. Dx I took on this side. Now this much is already there, you see. This is already there. Okay. So I don't want this minus sign. So I'll take minus on the other side. So sin x dx equals to minus dt. I'll place there. So this is equals to this minus, I'll keep outside. This is dt. Cos x was t, so 1 upon t dt. I repeat, what is this sin x dx? It is nothing but the minus dt. Minus I've kept outside, dt here, and upon this cos was t, so upon t. Now recall what's the integral of 1 upon x? That is log of mod of x. So here minus log of mod of t plus c. You must have noticed here, you must have realized here, formulas are very, very important, remember. If you are not going to prepare the formula, you are not going to learn minimum 3 to 4 chapters, remember. So every day in the morning you write formula 2 times, 3 times and memorize properly. So now minus log of mod of t. What was t? That is cos x here. Now you know one of the property of the log function, if you remember, this minus you can take in the power, if you remember. If you have n log x, you can write log of x raised to n. So this minus 1 will go in power. So this is log of cos x raised to minus 1. Raised to minus 1 means what? 1 upon n. What is this 1 upon cos? It is sec. So this is the proof indirectly. Okay. So this way you have, I've just given the idea, integral of tan is log of mod of sec x. This is a substitution method, a very powerful method, remember. But every time if you notice in any question, if you just notice this formula at the end, if you notice this is the standard formula. If you notice here, this is the standard formula. So all 19 formulas should be there in your mind clearly, remember. If you not learn it, you are going to suffer, not only in this chapter. Remaining 2 more chapters, we have such integration technique, remember. So don't ignore the formula. Learn it by any means. Just every day write 2 times, 3 times, you will realize. Now here one more standard result. One result we did, let me just again rewrite. These are some standard results for integration. One we did, if you have integral of fx equals to, for example, small f, big fx plus c, then integral of f of ax plus b, that is composition with linear function. Then what's your answer? F of, same answer, ax plus b upon, you know, here coefficient of x, which is a plus c, where c is constant of the integration. A should not be 0. This we did, already explained examples also. That's one thing. Now second result here, that says that if you have in this form f dash x upon fx, which form? Derivative upon the function, like this. Look at this. I'll write 2x upon x square plus 1. See this. One is this. One more. Let me write this. Cos x upon sin x. Cot function, if you remember. This is just cot function. If you see these two functions are of this form. Which form? F dash upon f. What's the derivative of sine? You know cos, remember. Derivative I'm talking. Such functions. Then the integral of this one, it can be proved by substitution, remember. Log of mode of denominator function. I repeat. Log of mode of denominator function. You know, in integration, whenever you have log, you need to put the modulus. Log of mode of denominator function. It can be proved by substitution. All are based on substitution. This is also based on substitution method. This is just a substitution method. How do I answer this? You know that this is f dash. You know this is f. So what's the answer? Log of mode of denominator function. X square plus 1 plus c. What's the answer to this? This is f. This is f dash. So log of mode of denominator function, sin x plus c. If you remember, this is cot. Just recall, you already written integral of cot x equals to log of mode of sin x. That is because of this only, remember. Okay. Now the same question I can do by substitution also. If you don't want to remember this formula, this question you can do like this. For example, I'll put denominator function equals to t, x square plus 1 equals to t. So what's the differentiation? You know, in integration, whenever you take the substitution, always you need to differentiate first. Why? Because we want to convert dx to dt. So here 2x equals to dt by dx I'll take this side. Now you see in this question, this much is already there. This is ready for you. This is dt. So this is equals to here dt. X square plus 1 was t, so upon t. Now what is the integral of 1 upon t? What's the integral of 1 upon x? Log of mode of x. But here instead of x you have t, so log of mode of t plus c. What was t? Tell me. T was x square plus 1, so it's getting the same answer. So this is the standard prepared result with the help of substitution. Here I did explicitly by substitution. Choice is yours. Whether you use this or you do like this, both are same, remember. So two important results. Number one, if function is composed with linear function upon the coefficient of x. If you have f dash upon f, then log of mode of denominator function. Log of mode of denominator function. Okay. And this is the way of doing. One more result, third result here, result number 3, that is like this. You have here function raised to some power n into the derivative of this one, that is f dash x, this function. I'll just show one example here. For example, suppose I have this integral of, let me write here 10 cube x into 6 square x. Now you see here sec square is not derivative of 10 cube. It is derivative of which function? Just 10, remember. What's the derivative of 10? That is sec square, f dash. So we are not differentiating fx raised to n. We are just writing derivative of f, which is f dash. Then by substitution method, it can be shown that the integral of this one is raise the power by 1 fx the whole raised to n plus 1 upon n plus 1 plus c. C is always there. N should not be minus 1 obviously, otherwise this will be 0. Raise the power by 1 divided by the same number. Increase the power by 1 divided by the same number. So what's answer to this? Derivative of 10 is x squared. So just raise the power by 1. 10 raised to 4, 3 plus 1 upon 4 plus c. This is your answer. You can verify if you differentiate this, you will get exactly the function this much. That you can do. One more, suppose I have this here. Log x the whole raised to, let me write 6 upon x dx. Now you can do, of course, as I told you, by substitution, because the proof of this one is substitution method. Remember, this is based on substitution only, substitution method. But we are writing directly here. You can write in the exam as well or in MCQs. So here you can rewrite like this. You see, I know derivative of log x is 1 upon x. So I'll write upon x as into 1 upon x. Now you see here, this is fx and this is f dash. I'm not talking about log x raised to 6. I'm just talking about log x. What's the derivative of log x? 1 upon x. So it's like this. If you raise to n into f dash, then increase power by 1. So I'll raise the power by 1. So log x raised to 7 upon 7 plus c. This is your answer. Increase the power by 1 divided by the same number. Fine. Okay. Now here one more. If I write, for example, let me write just one more question. Suppose I have let me write root of x square plus 2x plus 1 into, let me write 2x plus 2 dx. So you must have noticed, forget about the raised to 1 by 2. You just notice this. What's the derivative of this one? 2x plus 2, which is already there. So this is f, this is f dash. So you can raise the power by 1. What's the power here? 1 by 2 plus 1. So raised to 3 by 2. Why 3 by 2? Half power plus 1 power plus 1. As per this formula, it's plus 1, you know. So here 3 by 2 upon 3 by 2 plus c. This is your required integral. That's equals to 2 by 3 into x square plus 2x plus 1 the whole raised to 3 by 2 plus c. This just to illustrate. Remember, all this question, you can do by substitution as well. If you want to do by substitution here, you can put 10x equals to t. Try it now. I did 3-4 example. Put this. If you want to do by substitution here, try log x equals to t. You can do it. Remember, put this substitution. Put log x equals to t here. If you want to do this here, third question, put here alternatively, put x squared plus 2x plus 1 equals to t and go ahead. So these questions you can do by substitution as well, but I'm just stating the direct formulas. So after knowing these three results, composition with linear, you do like chain rule as we did in differentiation upon the coefficient of x, number 1. If you have f dash upon f, log of mode of denominator function. 2. Number 3, if you have this type of the form, power raised to n into derivative, raise the power by 1 divided by the same number. Now, I am just listing some points which would be useful to solve the questions of integration. So here next is points to remember for integration. These are not results, remember. So in every question blindly you cannot use this. But out of 10, at least in 9 questions, these points would be useful, remember. These are not results. As far as my knowledge or as far as my experience concerned, I have some list of points which would be helpful to solve the questions of integration. So I'm listing the first question, the first point is here. The first point is, if you have your polynomial function upon polynomial, then you don't have division rule, so you need to cancel the denominator expression, this denominator expression, with some factor here, and then you integrate it. Then you do the integration, number one. Number two, here if you have more number of terms in integration, suppose I have 1 plus 2 plus 3 terms, and I have a single term here, one term only, then what we do? Do individual division. This term upon this plus second term upon this term plus third term upon this term. Remember, individual division, distribution of the denominator. 1. More number of terms like this. If I want to integrate this, for example, x cube plus x plus 1 upon x. So how do? We do individual division. X cube upon x plus x upon x, which is 1, and 1 by x, and this can be integrated. Right? That's what I'm trying to tell you. More terms, single term, do individual division, because you don't have division rule. Fine. Number 3, third point is here. If you have such expression, you may have your root expression plus or minus, you have root expression again. Then what we do? We take the conjugate here. Conjugate. What's a conjugate? Multiply and divide with the same expression with opposite sign. You know conjugate now. So use conjugate and make it free from the square root. Fourth point. Now we just switch over to trig functions. If you have 1 plus or minus cos x, or 1 plus or minus sin x, 1 plus or minus sin, if you see usually these 4 terms, again take conjugate. Take conjugate. What you need to do? Take conjugate. Then it becomes easier, remember, little bit. Without these also it can be done, remember. So if you have in the denominator such root expression, plus or minus root, take conjugate here. You know what's a conjugate. If you have 1 plus or minus cos, 1 plus or minus sin, take conjugate. Out of 4, if any one of this is present, you can take conjugate here. Fifth one here. If you have sine square or cos square present, then we use this double angle formula. You know sine square is 1 minus cosine 2x the whole by 2, and cos square x, you know, 1 plus cos 2x whole by 2, 1 plus cosine 2x by 2, double angle formula. Sine square and cos square, for integration you need to use this double angle formulas, remember, right? Individually. Depends upon the question also, but normally this would be applicable. It may not be applicable in all questions, but this will do, remember. What I did, if you have sine square and cos square, remember, you use the double angle formulas. Sine square 1 minus cos 2x by 2, cos square 1 plus cos 2x by 2. If you have sine cube and cos cube, let me write here, sixth point, point number 6. That is, if you have sine cube and cos cube, sine cube or cos cube, if you have this, then use this formula. What's the formula for sine 3x? That is 3 sine x minus 4 sine cube x, you know it. And make the sine x as a subject of the expression. What is sine cube x from this? Interchange this. So here 3 sine x minus sine 3x the whole by 4. Use this. You can see RHS expression can be integrated very easily. You don't know integral of this, but this can be integrated very easily. 4 constant, 3 constant, integral of sine you know, integral of sine 3x also you know. So use this. Same way, use formula for cos 3x. What is the formula for cos 3x? You know it. Cos 3x equals to 4 cos cube x minus 3 cos x. And again you find cos cube from this and use this for integration. Remember, cos cube formula should be used, sin cube formula should be used normally. Remember, if you have sin cube and cos cube. One more point, 7th point here. If you have such bigger power like this, if you have sin raised to 4, cos raised to 4, tan raised to 4, such powers for example, then what you can do, use the concept of trigo. Use the concept of trigo and reduce into the smaller power. Okay, integration will be last one line in every question. If you have product of, like if you have two functions, sine square into cos square, or you may have sine cube into cos cube, then what you can do, you can multiply and divide by 4. 4 sine square into cos square. Why I am multiplying and dividing by 4, you must be knowing. So this will be just 1 upon 4. And what is this? 11th standard trigo, sine square 2x. How do you integrate sine square 2x? Now by double angle formula. That's the previous point, if you remember this one. How do you integrate sine square? That is using this double angle formula. Okay. What about this? Just recall, multiply and dividing by 8. That is 8 sine cube into cos cube. What is this? Recall this from 11th standard. It is 1 upon 8. What is this? It is sine cube 2x. You know it. This is nothing but, if I write 2 raised to 3, this is sine 2x. You know it. So I'm not getting into this. This is 11th standard trigo. Now how do I integrate sine cube? Using this, right? So this way, if you have sine square into cos square, multiply and dividing by 4. If you have sine cube into cos cube, multiply and dividing by 8. Okay. The next one, if you have product of two trigo functions. Next question, product of trigo functions. Product of sin x and cos x, that is trigo functions, like this. If you have sin x into cos x, now we don't have product rule. You may have cos x into cos 2x, like this. Then what we do, we use the factor formula. Use factor formula. Factor formulas. What are the factor formulas? You know, if you remember, s plus s 2sc, if you remember, s minus s 2cs, if you remember, c plus c 2cc, c minus c minus 2ss. Right? Use the factor formula if you have such product of two trigo functions. 9th point says that if you have such product, use the factor formulas. One more here, let me write. The next point, if you have normally log x or exponential function, the next point, point number 10 here, if you have log x function or exponential function, then take substitution, take log x equals to t or e raised to x equals to t, and then do further. Normally, not every time, remember. Okay, so let's recap all these 10 points. If you have such polynomial upon polynomial, cancel this denominator and integrate it, because you don't have division rule. If you have your more number of terms than this, then do individual division as I explained here. If you have square root like this, take conjugate. If you have 1 plus or minus cos, 1 plus or minus sin, take conjugate. If you have sine square or cos square, use these double angle formulas. Point number 6, if you have sine cube and cos cube, use the formula for sine 3x. You know 3 sine x minus 4 sine cube, and make the sine x as a subject of the expression. So interchange these two and you have this. Similarly cos 3x. If you have sine raised to 4, cos raised to 4, you may have like this, sine raised to 6 and so on. Such powers. Then use the concept of trigo and then you integrate it. Then do integration. Trigo concepts are important here. Next point, if you have sine square, cos square, sine cube, cos cube, multiply and dividing by 4, multiply and dividing by 8, and then integrate it. Simplify like this. Product of two trigo functions like this, use the factor formulas. What are the factor formula? You know s plus s2sc, s minus s2cs, c plus c2cc, c minus 2ss. And 10th point, that is, if you have exponential or log function, you can take the substitution and you can do further. So these are some 10 standard points which might be useful. The common technique is, you can use the substitution always, remember. Fine. Now later on, if necessary, we'll add further here. So in class book, you keep some half space blank. I'll tell you, okay, 11th number points is this and so on later on, not right now. As you go ahead, I'll tell you. So in your class book, keep some half space blank. So you can add here and keep on reading frequently this. So whenever you see the question, you can recall, okay, we have 1 plus cos x. So let's do this. We have sine squared, let's do this. We have sine cube, cos cube, let's do this. Right? So these points are very important, remember. Okay, with this knowledge, now we go to exercise 7.2.